Lesson 10, Operational Amplifier. Section 10.1. What is operational amplifier? This photo shows an operational amplifier IC. IC stands for Integrated Circuit. The model number is TL082CP, a product of Texas Instruments Incorporated. The package of this IC is called a dual inline package. DIP-type ICs can be inserted into holes of a breadboard. This is the symbol of an operational amplifier. Vin is the input voltage, and Vout is the output voltage. In and Iout are the input and output currents respectively. An operational amplifier is often abbreviated as op-amp. An op-amp is a DC-coupled high-voltage gain amplifier with a differential input and, usually, a single-ended output. The important characteristics of op-amp are: the first characteristic is high voltage gain. The voltage gain of an op-amp, AVOP, is defined as the ratio of Vout to Vin. In the case of the TL082CP, the typical value is 2 × 10⁵. The second feature is high input resistance. The input resistance, denoted as Ri, is defined as the ratio of Vin to In. The typical value of the TL082CP is 10⁻12 ohms. The third feature is low output resistance. RO is defined as the ratio of Vout to -Iout, under the condition that the input voltage source is short-circuited. This value is not listed on the data sheet of the TL082CP. However, RO equals several hundred ohms. Op-amps are used in a wide variety of applications in electronics, such as amplifiers, filters, and so on. Op-amps are found in almost all electrical appliances, including home appliances, cars, industrial equipment, and measuring instruments. Section 10.2. Capacitor coupled amplifier. This is a common emitter amplifier with a bias circuit. The capacitor C11 is used to couple the AC voltage source Vs to the common base amplifier. C11 is necessary to decouple the AC voltage source from the DC bias voltage. To achieve a higher voltage gain, the most commonly used technique is to connect 2 common emitter amplifiers, as shown in this figure. This is a 2-stage amplifier. The left and right amplifiers are called the first stage and the second stage amplifiers respectively. R12, R22, RE2 and CE2 are the elements of bias circuit for the second stage amplifier. Each transistor needs a bias circuit to set an appropriate bias voltage. VCG1 denotes the output voltage of the first stage amplifier, and VBG2 denotes the voltage across the base and ground of the second stage amplifier. In section 5.1, at the operating point Q, the DC component of VCG1Q was approximately 3 volts, and that of VBG2Q was about 1.3 volts. C12 is used to decouple the DC components on both sides, and to couple the AC component from the first stage to the second stage. The entire amplifier is called a capacitor coupled amplifier. VCG2 denotes the output voltage of the second stage amplifier. The total voltage gain of this 2-stage amplifier A total is defined as VCG2 over Vs, where VCG2 and Vs are the effective values of the AC components of VCG2 and Vs respectively. AV1 and AV2 denote the voltage gains of the first stage and second stage amplifiers respectively. The total gain is the product of AV1 and AV2. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.